2. So how do you find the vertex of a quadratic equation? Alright, so the standard form of a quadratic equation is as such. It is y equals ax squared plus bx plus c, where a, b, and c are coefficients. They can be negative or positive. They can be fractions. They can be anything. Okay, so this is what we call our quadratic function. Okay, so what they mean by a vertex is that if we were to plot out our quadratic functions on a graph, also let me make this black again, sorry about that. If we were to plot out our quadratic functions on a graph, they have two different orientations, okay? And these orientations are dependent on the values and the signs of the coefficients. We won't get into that too much. So we can either have a concave up parabola, so you can see it's like a smiley face, the smiley face is pointing up, or we can have a concave down, which means that it's facing downwards, like a sad face. Okay, so the vertex is either the max or min. So the max or the min of the parabola, and this depends on the orientation of the parabola itself, and this is what we call the vertex. So a vertex is either max / min of a parabola. So obviously one way that we can find the vertex of a parabola is by graphing it out and visually locating its vertex. So another way that we can use is that we can use this algorithm to find the vertex, okay? Alright, so let's say that we're given the standard form of our quadratic function, right? So we're given y equals ax squared plus bx plus c. Okay, sometimes you're not given this. Sometimes you're given it in a different form. But first you want to set it into standard form to locate your coefficients, okay? So the next step after you have your standard form is that you want to apply this formula. So this formula helps you to find the x-coordinate of the vertex, and that equals to negative b divided by 2a. Okay, so the x-coordinate of the vertex equates to the negative coefficient of b divided by 2 times the coefficient of a. Okay? Or coefficient a, I should say. So once you find the x-coordinate of the vertex, you can plug, oh my gosh, you can plug the x-coordinate into your function. So we're going to try to find the y-coordinate of the vertex by plugging your coordinate of the x-coordinate of your vertex into your function. So you'll have a times x vertex squared plus b times x vertex plus c. Okay, and once you find that, then you have your vertex, which is going to be x vertex, and this is also equal to y vertex, and a y vertex. Okay, so that's the method or algorithm of finding your vertex. You apply this formula, you plug in the x-coordinate of your vertex to find the y-coordinate of your vertex, and then you state it as it is. So this is one of the methods that you can use. You can also graph your function and visually locate it, or you can convert your standard form to the vertex form, and you can locate your vertex form through the actual form of the equation. But I believe that this is the simplest method of finding your vertex. Okay, so other than that, this solution is correct. Okay, let's move on to question number 3.